Hello friends, my name is Anshu Srivastav. Welcome to Never Stop Learning platform. I hope you are all doing well. Yeah, it takes a lot of times to interact with you. This is my first video clip in this year, which I am going to launch you right now. So wish you all the best and wish you Happy New Year as well as the 26th Republic Day. So we are going to introduce one interesting topic, that is electrical resistors. I hope you are all aware the electrical resistors, but just give some brief idea about this electrical resistors. So electrical a resistance is a measure of the opposition to the flow of current in an electric circuit. If you see on the top of the image, these are the actual resistors. If you go to market, you will see these type of resistors, and it has some color coding on that resistors. If you see, there are maybe 4 or 5 bands. So the second line is that it is influenced by the material properties, length, cross-sectional area and temperature. The electrical resistance is measured in ohms, symbolized by the Greek letter omega. So the symbol of resistance is a zigzag, and it may be also called a block. So it is there. So you must understand that whenever the resistance are in the electrical circuit, it only opposes the flow of current in a circuit, and the current is flow due to the potential difference or a voltage. Okay, now we understand the color coding of this resistance. If you see the right hand side of the image, there are 4 or 5 bands. So let me just if you see, the first band indicates the first band, second band is the second band, the third band is act as a multiplier, and the last band is a tolerance. So we will just study more in depth. The resistors are used in the electrical circuits to control or reduce the flow of current in the circuit. Their resistance is indicated by using electronics color codes. The different color bands or the rings are marked on this resistor for different values of resistance. So in a resistor there may be either 4 or 5 bands. So the color codings of resistor is different based on their values. Now let's understand the highlights of the resistor color codings. This is the same image, but it has different color codes: red, black, and this is your gold. So it usually contains 4 bands. The first band indicates the first significant feature of the resistance. The second band is the second significant figures. At times there is a third band to have more precision, and hence they are 5 band resistance. The third band is called the decimal multipliers. The fourth band is indicative of the tolerance in percentage that the register can withstand the indicated values. In the absence of the fourth band, a default tolerance of 20% is taken. If there is, I'm talking about the last band, the fourth band, if there is no band on that register, we can consider as default tolerance, that is 20%. We can consider. So this is the chart of the register by which we can calculate the value of resistance. So as we understand that first and second band is significant. If you see the second column, I'm talking about this chart, is indicate for first and second bands. The multiplier is dedicate for your third band, and the tolerance is dedicate for your fourth band. So according to the different color coding of our registers, you can identify the value according to this chart. So the register has four color bands. The first band is red. Okay, so you can just compare with that resistance. Let me just clear you this one: red, black, and gold. So the first band is red. That's why if you see in this chart, the value of red is your 2, right? So the digit is 2. The second band is also red. So the second significant digit is also 2. The third band is your multiplier, that is your black. Okay, see the image here, it is black, the third band. So black is where on the top, so it is 10 to the power 0. So for black, the multiplier is 10 to the power 0. Any number which has a power of 0 is equal to 1, right? So the fourth band is gold, which indicates a tolerance of plus minus 5%. Just see the gold, it has plus minus 5% this is in your fourth column, tolerance column. So hence the register has a resistance of 22 into 1. 1 is your what? It's a multiplier, right? Ohms with plus minus 5% is your tolerance. So this is the value. Okay. So now we are going to discuss about the relations of resistance, current, and voltage, and this is based on the Ohm's law. If you see here on the first image, the resistance are compressed both the ends, so it means that it reduces the flow of current. So Ohm's law defines the relationships between voltage, current, and resistance in an electrical circuit, stating that the current is directly proportional to voltage and inversely proportional to the resistance. According to Ohm's law, V equal to I into R. If the voltage is increased, the current is also increased, because voltage is directly proportional to current and the current is inversely proportional to resistance. So we can understand, according to Ohm's law, V equal to I into R. If you want to calculate the value of I, so I is equal to V upon R, and if you want to calculate the value of R, then R is equal to I upon V, like that. Just see the voltage here, we consider a battery, and the And you know that the currents flow always from positive terminal of battery to the negative terminal battery. Always currents flow from higher potential to lower potentials. And in this circuit, the resistance is also there, which is connected across this voltage. So resistor opposes the flow of current here. Okay. Now the types of materials and their resistance. Just understand that what the resistance you have seen here, it may be made of some kind of materials, right? So materials are classified by their electrical resistance into the conductors. It has low resistance, free electrons flow. When I'm talking about a conductor, and a good conductor is your copper, right? So copper, it has low resistance. When the resistance is low, it means the flow of current is more. Or free electrons takes place in the opposite directions where the currents flow in that circuit. Insulator, it has high resistance and restricted flow of currents, flow of electrons, right? Semiconductors, it is intermediate temperature dependent resistance. The metals like copper, silver and gold are excellent conductors. And if you noticed that gold, silver and copper, I'm talking about gold and silver, they are considered as a tolerance there, right? The materials like rubbers, glass and plastic act as an insulator where the current does not flow. Okay. So we just include the resistance in this circuit. If you see, the battery, a cell act as a battery. There are three cells connected in series. Okay. Resistance is there, load is there, light, lamp and switch is there just to make the circuit on and off. A resistor is composed of conductor, right? Means in this circuit a conductor is plays an important role just to connect all the components like resistor, lamp, switch to cell. So power source, load, resistor and switch. A circuit starts and ends at the same point. Usually the copper wire without insulation is used as a conductor. A switch is used to make or break a circuit. Resistor control the flow of electric current in a circuit. A resistor is a passive element, which means that it only consumes power but it does not generate power. Note this point. It is very important that here the resistance work as a passive element and it only consumes power and it does not generate power. A load, your bulb, your lamp, in a circuit consumes electrical energy and converts it into other form of energy like light, heat, etc. A load can be a light bulb, fan, etc. Okay, so you understand that what is the importance of resistance in a circuit. So it is connected, it may be connected in series, it may be connected in parallel. We will see in some more videos later. Thank you for watching my channels. Viewers, please subscribe my channels. Kindly put your comments so that I can upload more useful contents on these platforms. Thank you very much.